All right, so now that we've had that quick review, we're going to go into uncompensated, partially compensated, and compensated states. So I am going to use this red to represent uncompensated, and I've already filled in some of the chart because one of the things we know we have to look at is pH. pH lets us know whether this is acidosis or alkalosis. And then we said we'll look at CO2. If the CO2, again, is off, then we know that it is a respiratory state because typically your HCO3 is going to be normal if it's respiratory acidosis or alkalosis. On the flip side, if it is a metabolic condition, we know that our CO2 is going to be a normal value and it's going to again be our HCO3 that is off. So just to quickly go over this, of course, if it is acidosis and it's respiratory, the pH is down. If we think about Rome, we know our CO2 will be up or increased. And that makes sense because we just said that the CO2 mixes with water to make carbonic acid. We would have more of that, which contributes to an acidic state. On the flip side, we know if our pH is up, and this is alkalosis, and again, Rome, we know our CO2 is down. We have less CO2 to mix with water to make carbonic acid, which makes sense that this is a more alkaline state. When we look at metabolic, again, pH same, okay? Our pH has to be less than 7.35 for it to be an acidic state. This will be normal when we look at our CO2, but then when we look at our HCO3, remember Rome metabolic equal. So we know that our HCO3 is also down. Knowing that that's bicarbonate, it makes sense if we have less of this alkaline substance in our system. Makes sense that we're then more acidic. On the flip side, when our pH is up or above the 7.45, if this is metabolic, we know that again, equal, we must have more of the HCO3 in our system, which again goes with a more alkaline state. So just a quick review of some of the content that I went over last week, and now we're going to get into if it's partially compensated.